determine domain and range. No, range no. Domain, just domain is easy. Range is more complicated. And that part no, using the equation. In this case, it's giving one equation of the line. Of the line, no, of the function, sorry. No line, function in general. And you determine the domain. So what is the idea? The idea is the supposition. You assume that the domain is all real number. Is from negative infinity to positive infinity. But sometimes we have restriction. This is you remove, discard, subtraction, restriction, minus restrictions. And the restriction you have in three fundamental situations. Restriction number one, when you have a fraction, I need to avoid the denominator of the fraction non-zero. Because you know it's illegal divided by zero. So I don't care, you have fraction p divided by q. P is a algebraic expression, q is another algebraic expression. So to investigate this, you take p, q, no p. P is you ignore, not important. And you investigate the value of zero. Number two is when you have square roots, any expression, you take the expression inside the square root, and this expression must be non-negative. Because you know when the expression is negative, the answer is imaginary. In this chapter, I don't want to work with the imaginary number, only real. Look at the supposition, all real number. And number three is a combination, this and this, is supposed to be p divided by radical e. In this case, radical e is positive. Because there's the combination, both situations, no negative and no zero. Okay? So let's do in and their combination. Okay? Combination. Let's see example to understand how you determine domain when the equation of the function is given. Equation one, example one, sorry, I am crazy. Example one, suppose a rational function like that, f of x, using function notation, x plus 4 divided by x squared minus 2x minus 3. Okay, this is similar restriction number one. So the supposition is all real number, but I need to investigate when the expression in the denominator is x squared minus 2x minus 3 is non-zero. It's a restrictions. Okay. Now, to investigate this, in my opinion, it's easy convert this inequality to equation because I am familiar of the solution for the quadratic equation. We are strong doing this. In this case, by factorization is possible. Is 3 and 1, no? 3 times 1 is 3, and somehow 3 minus 1 is 2. So the sign is negative and positive. Therefore, it's obvious that one solution is 3 and one solution is negative 1. Actually, see, we continue doing this problem using this symbol. This is this symbol, no equal. So this is the restriction. This is the bad guy. This is the number that you exclude inside the domain. So how you present the final answer? Well, the final answer is easy. Look, you have all real number line, like that. It's a line, horizontal line, que represent all real number. Cool. From positive infinity to negative infinity. And 0 in the middle. And the bad guy in this game is 3 positive. 1, 2, 3, and negative 1. Therefore, our domain is any value from negative infinity to negative 1. In negative 1, we have a hole. And we continue from this to 3, we have another hole. And from 3 to infinity. Now, basically, we have here one hole, and we have here another hole. So what is solution? The solution is domain of the function f, is the name of this function, expressed in interval notation. Basically, we have 1, 2, and 3 intervals. It's from negative infinity, comma, negative 1, parentheses, remember parentheses when there's no included, union, negative 1, comma 3, union, 3, comma infinity. End of story. Final answer expressed in interval notation. Everyone follow me?
Yes.
Cool. Let's move on to example 2. Example 2 is a little bit different. It's a function also, g, let me call g. And g is square root 3 minus 2x. Again, the same, determine its domain and express the answer in interval notation. Well, this is look like similar to the restriction number 2, que es the restriction que contain a square root, pero en el numerator, no en the denominator. Okay, no problem. Entonces now you take the expression inside the square root is 3 minus 2x, and you enforce it to be greater than or equal to 0. And you ignore the square root. My goal is investigate what value this expression inside the radical is positive or 0. Non-negative, non-negative. Okay, let's do in the inequality. Inequality is minus 2x greater than or equal minus 3 divided by negative 2 both sides. Okay, now x, be careful because when you divide inequality by negative number, you have to reverse it, the direction of the inequality sign, that is 3/2. 3/2 is 1.5. So now see, I want to represent graphically, I like that. Not always necessary, but I like that to understand much better the problem. This is my all real number line. This is infinity positive, this is infinity negative. This is 0. This is 1, this is 2, no? Pero this is 1.5, is here in the middle, yeah, 1.5. 1.5 is 3/2. Therefore, my domain is the number less than or equal, so you highlight this, less than or equal 1.5, in that direction. Include 1.5, of course, yes, include 1.5 because equal sign means can include 3.5, 3 over 2, 1.5. You represent like a bracket here. The domain of G is equal from negative infinity, comma, 3/2. Bracket. Because include 3/2 inside the domain. Because 3/2 is good. 3/2 give me a real number. Everyone follow me?
Yes.
Yes, sir.
Example 3, similar. But in this example, bring me the name of the function is h. This is 4 divided by square root x minus 9. Oh, this is again square root, but the square root in the denominator is similar to the restriction 3. Because when you have a square root in the denominator, look here. Entonces similar except no zero. So you convert this problem, you take the expression inside the square root and enforce it to be positive. No zero, no equal, no, because equal zero, the denominator is totally illegal. And no negative, so positive, just positive. And solve this inequality, super easy. Is x greater than 9. Okay, now always you try to express your domain in interval notation. Infinity positive, infinity negative, 0 here in the middle, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It's greater than. Is this interval. Continue forever to infinity, but no include 9. No equal 9, no include. The domain of h function is equal parenthesis 9 comma infinity parenthesis. Cool?
Yes.
We have a lot of examples of this because I need to train it to you in this way. Okay. Example 4, bring me new situation. Example 4 is, suppose the function p is the name. Remember, the letter is the name of the function. S equal, frequently name of the function is one letter, f, g, h, p. Sometimes using two letters when it's a specific function. We studied in the chapter 3. One function is lm, g, log. So basically, one letter, two letter, or three. No four, never four. The name of the function never is Maria, Jose. Only one letter, two letter, or three letter. This is the frequent idea. Suppose this example in which the function is x over x squared plus 1. Wow, it's a fraction. So I suppose que corresponde with the typical restriction 1 is p divided by q semicolon q not 0. So you immediately you take this expression and you investigate what value is not 0. Again, and this is not comfortable for us, and you put it like that because I feel more comfortable solving the quadratic equation. But in this case, look, x squared, I move 1 to the other side, -1, and you apply square root. So x equals square power and square root cancel out each other, and this is plus or minus I is imaginary, it's exactly I need to avoid. Therefore, the interpretation is, you try to investigate, you are doing your will. You take the expression, and when you have the solution, imaginary or complex, that means that the restriction that you try to looking for don't belong to the real field, living in another field. Therefore, we have no problem in the real numbers. Therefore, the domain of P is a real number. Okay, do you understand this or no? Okay. The restriction is the bad guy. But see, when you solve the equation, the bad guy belong to another field, not in the real field. That means in the real field we have no restriction. If we have no restriction, the domain is a real number. Cool?
Yes.
Let me try one more complicated. Suppose example 5. Example 5. Remember, we have a function, let me call f again. Is equal square root x plus 4 plus another square root x minus 5. And you apply the same thing. The problem is that this example bring me two radical. Okay, no problem, I understand. Now you apply one more time the restriction number 2, que say And when you have a function that is square root e, you guarantee that e expression must be non-negative. But you have to write that. That's what should I do, Professor? Why don't you take both? X plus 4 greater than or equal 0, x minus 5 greater than or equal 0, you take both. And you connecting both inequality by and conjunction. Because you need to satisfy the first and you need to satisfy the second, both, simultaneously. And you convert the problem in one compound inequality. This is compound inequality. Okay, no problem. This is easy. Use solving both separately, x greater than or equal minus 4, done, and x greater than or equal 5. Now, finally, as always happen, you are doing your all real number line. You put both together. Okay, this is the hypothetical idea. Domain is all real number. Okay, and this is the restrictions that we have in the problem. And you copy one by one. This is 0 in the middle. We have 1, 2, 3, negative 4 here, and 1, 2, 3, 4, and 5 here. Okay, corresponding with this. Let's do in this part first. This part is from 4, but to the right, in that direction. Because greater than is to the right. No? Include 4, yes. Bracket. And let me use another color. This is the gray color. However, I'm using another, maybe green for this. It says for 5. For 5 gets this. In the another direction. But let me try. Okay, this okay. Include, of course, include 5. Okay. Now this is a crucial moment to perform an operation. And means intersection. Intersection means common element. Entonces, my question is now, what is the interval, or what is the piece of interval in which both inequalities share is common? What is this? So what is the common part between gray part and the green part?
The 5.
The 5, very well. The 5, the green part. So basically, the conclusion is domain of the function f is bracket 5, comma infinity. Let me try to checking. How we can check in here? Well, okay. Suppose you pick arbitrary crazy value. Suppose, okay, I pick one guy here, negative 5. It's completely out the domain. I pick another guy here, 0. Gets completely out of the domain. I pick one guy here, gets 6, gets inside the domain. To guarantee to check it, no, not necessary to do, but just in case I want to illustrate the idea. Suppose plugging in negative 5. Plugging in negative 5 into the original function. It's square root negative 5 plus 4 plus square root negative 5 and another negative 5. This is obvious is negative 1. And square root negative 1 is imaginary. Is at least 1 is imaginary, thus is completely undefined. And the answer of this actually in the real field is no, it's undefined. For both reasons, because it's negative 10, no? Ahora, suppose que evalúe en 0, que es another guy here. This satisfies the first radical, but not satisfies the second, no? Pero I have no idea. Is you copy 0 plus 4 plus square root 0 minus 5. 0 plus 4 is 4, and square root 4 is 2. Real, nice. What is the square root negative 5? Okay, again, it's imaginary, therefore undefined. Okay, this is okay, but this is not okay. And to be okay, you need to be okay both and. This is the idea, and. Suppose 6. Okay, suppose it's okay. It's a square root 6 plus 4 plus square root 6 minus 5. Okay, 6 plus 4 is 10. Square root 10 is a number. Of course, irrational, but it's a number, real. And 6 minus 5 is 1, square root 1 is 1. And it's a real. Therefore, it's totally defined and it's the domain. Cool. Entonces, the domain is the interval star and phi, include phi, so phi is possible, evaluate. Look, this is 5 plus 4 plus square root 5 minus 5. I am plugging in 5. 5 plus 4 is 9, square root 9 is 3. 5 minus 5 is 0, square root 0 is 0. It's 3. Get 3. Do you understand very well the idea or no?
Yes.
Okay, so when you have different radicals, you take one by one and you convert in one compound inequality, you solve each inequality separately, and finally we connecting by hand. And remember it's an intersection. Let's see another example that bring me new complication. Suppose. Example 6. In example 6, we have function like that. G of x is equal square root 2x plus 1 divided by x minus 4. Okay, entonces the same question. Determine domain of G and express your final answer in interval notation. How many restrictions you can see? Okay, restriction number 1, remember, is when you have P divided by Q and Q not 0. Actually, you take the expression in the denominator, okay, is x minus 4. And this expression must be not 0. No, illegal. And the expression inside the square root gets 2x plus 1 must be non-negative. This is a restriction here I need to solve. It's easy. It's x not 4. 4 is illegal value. And 2x greater than or equal minus 1. I move this positive 1 to the right hand side like a negative 1. Negative 1. And divided by 2 both sides. X is equal. And remember, when you divide by a positive number, the inequality sign stays the same. Okay, ready. And we're connecting this and this. Let me try. This is my rule. This line represents all real number. And infinity positive, infinity negative, 0 in the middle. 4 is here. 1, 2, 3, 4. And 4, guys, we have a whole. Yes or no? Illegal 4. And negative 1/2, que is this? This is negative 1. This is negative 1/2 here. Negative 1/2 is to the right. Is to the right. To the right. But unfortunately, when you go to 4, it's a hole. You jump the hole and continue forever in that direction. So now be careful. Now we have here equal sign, including negative 1/2. Basically, to write domain of G function is that piece, que es bracket negative 1/2, comma 4, parentheses, because do not include 4, union, because it's 2 pieces, and you connecting the pieces by union, que es or, no and, bracket, no, bracket no, paréntesis, 4, infinity. Okay. In that case, actually, yeah. You say, bueno, professor, bro, this look like this is or. However, you say here and. It's confusing, no? So you are doing, for example, look, let me show you. Let's do it step by step. So you are doing, for example, the representation. Let me do 2 or real number line. The representation for that part is this is 0, 1, 2, 3, 4, and 4. You know, okay, we have a whole. Actually, this represents all real number except 4. That part is okay, and that part is okay. The only whole is 4. And the other part is in negative 1/2. This is 0 again. And this is negative 1/2 here, negative 1/2. Entonces is that part. Incluye, of course, negative 1/2. And basically, you need to do the AND operation in between these